Welcome back. All right, so here we have, now we're going to be solving with more than one log on a side. All right, so what to do when we have more than one log on a side. This, by the way, is in your notes. See that black box? I guess in the original notes, I had this page as colored, so you could see the yellow nicely. And when I printed it, well, you couldn't see the words very well. So sorry about that. If you stand in like really good light, you could see it. But otherwise, you could just use a little sticky note, cover it up, and write this down. And I'll underline the key things here, right? So you don't even have to write everything down. So this is solving logarithmic equations with more than one log on a side. There's our title. Number 1, condense. Use logarithmic properties to simplify to get a single logarithm, one side or both sides. All that means is condense your log, right? If you've got more than one log on a side, condense it. You're using the product rule, you're using the quotient rule. Okay? Once you condense, you have log A equals log B and those bases match, then you can remove the logarithm from each side, drop the log, and just set what follows equal, just like the problems we did in the first part. If you have log equals a constant, then you'll just change from logarithmic form to exponential form and solve. So basically, you're going to be the problems here are the exact same ones we just did, except you've got to simplify first. Once we simplify, once we condense it, we're going to have one of these two other types, right? Because we're not going to have two logs. We're going to simplify the two logs to one. And when we do that, we have log equals log, drop the log, set them equal. If we have log equals constant, we're going to rewrite it as base raised to a power gives us an answer and solve. All right? So really, we're just putting things together. We're not really learning new things. We're just learning to put things together. All right, so here's the first one, and I believe it's on the back side of your notes. Yes, I'm correct. All right, so here we're going to condense both sides first if necessary, and you can see only one side needs to be condensed. All right, it's the side with the two logs. All right, so we have log base 3 of 6 equals log base 3 of 3 plus log base 3 of x. The product property to condense the log. All right, so the sum of logs equals the log, singular log of a product, right? Because when you multiply bases raised to a power, you add the exponents. Well, logs are exponents. So if you're adding exponents, it means you're multiplying like bases raised to a power, or like base is 3 here. So log base 3 of 3 plus log base 3 of x condenses to log base 3 of 3x. And if you have trouble with any of the condensing on this one, watch the podcast again on condensing. Right? Just review that one. I go through all kinds of condensing and expanding problems. All right, so now once we've condensed, we have log base 3 of 6 equals log base 3 of 3x. We have log equals log. And we know that x equals y, 6 equals 3x, if and only if log base 3 of 6 equals log base 3 of 3x, right? If the bases match, what follows is equal, so we can drop them. So now we have 6 equals 3x and x equals 2. How simple is that? Now, the only thing is we have log equals log, not log equals number. And so if you've got more than one, anytime you have more than one log, let's just put it this way. So put this in your notes, right? You must check your solutions anytime the equation has more than one log in it. Right? Because as soon as we get more than one log, that's where things can happen. That gives us some false solutions, right? Because we drop the logs just because we set what follows equal to one another. If it doesn't work in the log equations, it's not a good solution, right? So here, let's check our solution and make sure it's okay. So log base 3 of 6, good. No problem there. Log base 3 of 3, no problem there. It's a positive number, plus log base 3 of 2. All right, does that work out? Well, log base 3 of 6 is equal to log base 3 of 3 times 2. And yes, that does work out. That checks out perfectly fine. Log base 3 of 6 equals log base 3 of 6. Perfectly good solution. Right? No problems there. So add that little check and add about checking anytime you have more than one log, because problems can happen when we have more than one log. And sometimes we get solutions that aren't solutions. Let's solve another one. All right, so here we have another example. This one was not in the notes. Of course, you can always write them down. All right, I have log 16 equals x times log 2. Notice I can't just do, hey, log equals log, let's drop it. No, you can't do that, because that's not log 2x, that's x log 2. So I got something with my log, and it's not like I could very well divide both sides by x and make it any better. I'd just make it worse. I need to make it log equals log, not something times log equals log. Well, we can use our power property to condense the log. But this is actually a pretty good one that I should have included in your notes. Feel free to squeeze it in anywhere you want, or add a little sticky note. So that x there goes back on the 2 as an exponent using our power property. So now I have log 16 equals log base equals log 2 to the x. Now I can drop the logs, right, because I have log equals log, right? So 16 equals 2 to the x power. And now this is an easy exponential to solve because 16 is the same as 2 to the 4th. The bases are the same, so the exponents are equal. So 4 is equal to x, right? And let's check our solution. All right, so we have log 16 equals 4 times log 2. And now I can simplify that. The 4 can move back. Log 16 equals log 2 to the 4th, and 2 to the 4th is 16. Log 16 equals log 16 is irrational, but a perfectly good solution. All right, we're done with that one. Let's do another one. All right, so checking for some extraneous solutions. This one's in your notes on the side. Oh, I did have that one in your notes. I lied. This one is in your notes. I just didn't notice it in the little shaded box when I was looking at it. So just make sure you don't have to, you've got it right there. You don't have to rewrite anything. Just make sure you add the check to that one. We like to make sure anytime we have more than one log that our solution is good. All right, so if you need to, pause the tape. Otherwise, we're going on. So checking for extraneous solutions, and this one is in that on the side there, all filled out for you. I think all filled out. All right, so sometimes condensing a logarithm results in a quadratic equation which must be factored. When factored, there are two solutions. However, one solution may be extraneous, result in an untrue statement when substituted back into the equation. In other words, a false solution. So that's what I say. Anytime we got more than one log, whether it's log plus log or log equals log, we have to check because we can get those false solutions. It works in the equation, it just doesn't work with log. All right, so log x plus 2 plus log x minus 1 equals 1. We can use the product property, or product rule, to condense the log because we know the sum of logs is equal to the product of a single log. So log x plus 2 plus log x minus 1 is the same as log x plus 2 times x minus 1. Notice only one log there. Now we need to simplify that, so we have to multiply because we can't solve it the way it is. So we have x squared plus x minus 2 equals 1 when we multiply. Right? So it's just x times x is x squared. The outer terms, x times negative 1 would be a negative x. 2 times x would be 2x. 2x minus 1x gives us the x, and 2 times negative 1 is negative 2. Right? So I didn't really write in all the steps on the multiplying. Maybe I should have. I'll just add them over here just to make sure that, nobody has any questions. X plus 2 times x minus 1 is just x times x minus 1, oops, plus 2 times x minus 1, which gives us x squared minus x plus 2x minus 2. And that is equal to x squared plus x minus 2. Okay? Just to make sure nobody had any questions on that. All right, so now we have log equals a number. We need to rewrite that as an exponential. All right? So the result is equal to the base raised to a power. When there's no base written, we know it's 10. So x squared plus x minus 2 equals 10 is the base to the exponent is the first power, 10 to the first. All right, and that's just 10. So now we need to factor this, so we're going to have to move everything to one side, so we'll subtract 10 from both sides. We have x squared plus x minus 12 equals 0. And I did the factoring on the side there, so you could just check that out. Multiplies to give you negative 12, adds to give you 1 was 4 and negative 3, and there's all the steps over there, and you even have those in your notes. So we have two solutions here. When we set them both equal to 0, we have on the other slide, we have negative 4 and 3. All right, and we do have to check both of them. All right, so we have log x plus 2 plus log x minus 1 equals 1. Let's check the 3. So that gives us log 3 plus 2 plus log 3 minus 1 equals 1. 3 plus 2 is 5. And 3 minus 1 is 2. So we have log 5 plus log 2 equals 1. It's hard to tell if that's the solution, right? Until we condense it. So product rule, condense the logs. Log of 5 times 2, which is 10, does equal 1 because 10 to the first equals 10. That checks out. That's a true statement. Log 10 is equal to 1. All right, let's check the other solution, which is negative 4. So log of negative 4 plus 2 plus log negative 4 minus 1 equals 1. As soon as you get a log of a negative number, stop. Right? See the stop sign there? Stop sign saying stop. It's not a solution. Do not multiply them together. All right? It'll just hide the fact that this was not a solution. All right? Because the negatives will cancel out. But if you try, but log negative 2 plus log negative 5 does not equal 1. Because you get error plus error, and error plus error doesn't equal anything. Right? So this is not a solution. If you have log of a negative number, stop. Do nothing else and know that this is not a solution. So there's my stop sign. Feel free to put a big old stop sign in your notes as well so that you stop and you don't keep checking. Oh, it looks like my checks are I didn't give you a copy of my check. So go ahead and write in those checks in there. I gave you a space for it and I gave you the steps, but I didn't actually give you all the steps for the check in your notes. So just pause the tape and fill that in and put a big old stop sign when you get to the one where it says no solution, because you want to make sure you don't try and condense that, because that's false. All right. Maybe we can do one more problem before I end this podcast. And this one's in your notes. We have log base 6 of x plus 5 plus log base 6 of x equals 2. So let's check this one out. All right, we have a log plus a log. 2 logs on one side. We need to condense the logs first using the product rule. And it helps to write in the n. There we go. So condense logs using the product rule or product property. All right, so this becomes log base 6 of x plus 5 times x equals 2. All right, we have log equals a number. So we want to rewrite into exponential form. All right, so Actually, before I do that, one little thing we should do first. Why don't we simplify that first? Not that we couldn't rewrite it and then simplify, but let's just simplify that first. And then let's rewrite it. All right, so we have log base 6. If we distribute the x to both of those terms, we're going to have x squared plus 5x. I'm going to put parentheses around that because it's the log of that whole thing. That equals 2. And now we'll rewrite it. All right, so our result, x squared plus 5x, is equal to our base, which is 6, raised to the power of 2. All right, now we'll simplify, because we could simplify out that exponent. And we have x squared plus 5x equals 36. We want to set the equation equal to 0. So we're going to have to subtract 36 from both sides. So we have x squared plus 5x minus 36 equals 0. Multiplies to give us, so 1 times negative 36 is negative 36, multiplies to give us negative 36, but adds to give us our b term of 5 would be negative 4 and 9. Right, so we have, I should have written it a little bit smaller. Maybe if I move everybody up a teeny bit, because I'm starting to run out of space. Up, 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 up. And move you up. There we go. All right, so, and I'm going to do the factoring over here. I guess it doesn't really matter. I'll do the factoring over here. All right, so we have x squared minus 4x, and then plus 5x minus 36 equals 0. And then we'll factor out the x. We have got an x minus 4. Factor, oops, sorry. And nobody said anything. I put a 5 instead of the 9. Silly me. We'll factor out the 9, and we have x minus 4. And so our factored, we have x plus 9 times x minus 4 equals 0. And that means if we set them both equal to 0, if x plus 9 is 0, x equals negative 9. If x minus 4 is 0, x equals 4. All right, and now we need to check those solutions and see if they're any good. Did I leave myself space on the next page, or do I have to cram it in here somewhere? I left myself space on the next page. All right, you'll have to cram it in there somewhere. All right, so we had the two solutions, x equals negative 4 and x equals 9. Let me just double check that. I was pretty, or the other way around, sorry. X is 4 and x is negative 9. Got the signs backwards. Actually, I should have realized that because it was x plus 9. That when we factor, this would be a negative 9, and this would be a positive 4. All right, so let's plug those in and check. All right, so let's just check them in order. All right, so for the x equals negative 9, we have log 6 negative 9 plus 5 plus log 6 negative 9 equals 2. And that's log 6 of negative 4 plus log 6 of negative 9 equals 2. And now you may stop. And it is not a solution. Log 6 of negative 4 is nonsense. There's no number you're raising 6 to get negative 4. It's always positive, right? Do not multiply them together and just hide the fact that this is not a solution. All right, not a solution. Just stop as soon as you get log of a negative number. Let's try the other one. X equals 4. We have log base 6 of 4 plus 5 plus log base 6 of 4 equals 2. So far, so good. Log base 6 of 9, that's positive. Log base 6 of 4, positive is 2. I can condense these ones because they're both positive, right? These are real numbers. So I have log base 6 of 9 times 4 equals 2. That gives us log base 6 of 36 is 2. And that's a true statement, right? Because 6 squared is 30. 36. All right, that is a true statement. That checks out. Good solution. So this one is a solution. This one is extraneous. All right, don't use that one. All right, so I'm going to end this podcast because I think, especially first period, you had to watch the very first podcast, so it's had enough. And so we'll solve this problem that's in your notes in class, and we'll solve the one after that one that's in your notes in class, and that's what that's all we're going to do. We basically finished solving logarithmic equations on our podcast here. So in class, we'll do the rest of those, and we'll do the whiteboard practice that you see right here. All right, have a nice day. Bye-bye. Thanks for watching the podcast.